Hello everyone, and welcome to Total Materia, the world's most comprehensive materials database. Total Materia is not just a curated materials database, it's also a great decision-making tool for optimal material selection. Throughout the presentation, we're going to go over Total Materia's capabilities as well as functionalities. Firstly, on the home page, you could change your language preference. There's 26 different languages to choose from. You could see when your subscription is expiring, as well as you have a link to return to the older version of the platform. You can register for upcoming webinars in different languages. We have a new interface webinar monthly that lasts about 30 minutes. You could access previously saved recordings of different webinars in different languages and access guided tours for each module and submodule we have at Total Materia. You could also access that guided tour at the bottom of the page when you're on a specific module. And lastly, you could always contact us if you have any questions on how to find different material information on the site, as well as if you have any suggestions for us. Next, you can find all the different data modules and functionality modules over here at the top of the page. Firstly, we have Total Search. That's where you can find basic physical, mechanical properties of both metallic and non-metallic materials, their chemical composition, as well as different heat treatment diagrams and metallography diagrams for metallic materials. Next, we have our extended range module. You could explore testing data such as stress strain diagrams, formability data, fatigue data, fracture mechanics data, as well as creep data. Next, we have Data Plus. Over here, you could explore different joints data from welding, brazing to adhesion, coatings and dimensions, tripology data, as well as lubricants and coolant. Under Enviro, you can find corrosion, aging, weatherability, and irradiation data. Now under Compliance, you can find compliance information of different non-metallic materials as well as substances, and utilize Compliance Assessor, a tool where you can instantly see which materials are compliant to regulations, and that includes metallic and non-metallic materials as well. Lastly, our last data module, Suppliers, giving users the ability to find producers and distributors across the globe. Next, we have our functionality modules. Under Smart Comp, you could identify unknown metallic materials. You could also perform reverse engineering through QA mode. Under Exporter, you could access previously saved exports that you've done for different materials, which we're going to go over later on in the presentation. And under Tracker, you could find out on a material level which of their properties have been changed, withdrawn, or taken out of the database. Lastly, Material Console is the reason why Total Materia is such a great decision-making tool. Material Console gives its users the ability to create and share material lists and reports, compare different materials, which in turn can increase efficiency and speed up the internal decision-making process. Plus, you can access favorited materials. You can access previously saved bookmarks. You could also access your saved searches, material lists, and saved reports. Now, how do you actually utilize all these different data modules and functionality modules? How could we actually find different material information on Total Materia? Luckily, on Total Materia, we have 4 different ways to find materials. Under Quick Search, if you know your numerical and alphanumerical designation, you could quickly type it in. But if you don't, you could also search by different types of materials, different material groups, different standards, as well as type in a producer that you want to find material information on. Next, we have Advanced Search. If you don't know which material you need to use, but you have certain decision criterias, let's say you want your chemical composition to have a certain percentage of carbon, you could quickly just select carbon and add in your specific range. You could also limit your tensile strength, meaning if you want a minimum of 200 megapascals, you could add in a number here between a specific temperature. Similarly for physical properties, and under Special Search, you could actually find materials based on their heat treatment diagrams, as well as metallography data, machinability data, and magnetic properties. And of course, that's best utilized for metallic materials. And under general information, you could select your material groups, your standard. Next, you could find materials through standard lists. So let's say we want to find all the different EN standards. We could quickly type in EN here. You could search by different standard numbers as well as their ICS number. And if you want to see which standards were withdrawn, just click on status, and then you could see which of these standards were withdrawn, which of them were replaced, and which materials were in that standard. Material discovery is a great tool to use when you start your material selection process. It gives you the ability to add in different property criterias that your design needs to uphold. So let's say we want to find a material that has a yield strength of at least 400 megapascals, as well as a tensile strength between 900 megapascals. Our search coincides with ferrous alloys, non-ferrous alloys, polymers, and composites. And let's say I want to do more research on different non-ferrous alloys. Very large range for non-ferrous alloys. And if I double click, I could actually see based off of different groups, so different non-ferrous alloys, aluminums, and coppers, how those actually compare between each other. So this is more on the material group level, whereas under quick search, advanced search, and standard list, you could find specific materials with their designations. As an example, let's search for a popular ferrous alloy called 304 AISI. I could type in the designation here. Also the SDO acronym beside my numerical designation, but I could also choose the standard over here. The first material that popped up is the one that I'm looking for. The homepage of every material will look similar. At the top of the page, you could quickly favorite this material. In case it's a frequently used material, you could see its standard, material group, so it's a ferrous alloy, and a stainless and heat-resisting steel, as well as a new feature we've added, an indicative price. You could also switch the currency and see roughly how much dollars would this material cost per kilogram. It's a rough estimate, and if you click on more information, you can see how we came up with those prices. You could add your material to Material List Builder in case you want to build up a material list. You could add different diagrams as well as data to Report Builder, and you could export different data to different CAD solvers and CA solvers, as well as bookmark specific pages. All the bookmarks, as well as the favorited materials, you could always re-access under Material Console. If you search by material through Total Search, you're always going to be defaulted to either its mechanical properties, physical properties, or chemical composition, depending on the types of different data the material has. And mechanical properties and physical properties are set up in a similar way. We have a synthetic view as well as a details view. Under synthetic view, you could quickly see the range of different properties that we have available, let's say under room temperature. If you want to find all the properties available over 300, you could quickly select that. And as you see, the range changes. But if you want to do more serious digging on the material, you could quickly just click on Details View. You could see all the different references we have available. You could actually choose by official references, so material information from SDOs, as well as other, meaning different engineering textbooks or online sources. You could also change the temperature at which you want your conditions to be at. As you see here, we have 179 out of 182 conditions under room temperature. We have one condition selected. You could also select more than one condition to quickly compare those different properties, and you could see all the references listed for the selected material. As you see, we have 40 different references for this material. Imagine how long it would take for you to find all this different material information from these 40 references, as well as money. So, for example, we're going to add in some sort of heat treatment. So if we choose a yield in the form of bars, we have 3 different conditions. If we want to compare all the different conditions at the same time, we could just quickly highlight those and either group them by condition or by property. Let's say we just want to compare the first condition. We want to look at its yield strength. We could quickly zoom into the diagram. You could use the toggle spike line to quickly find different data at different temperatures. And luckily, we could actually add this diagram to Report Builder in case we want to share it with someone later on or download it to have it under our files. And the best part, you could actually view all these different diagrams and add them all to Report Builder. So if we just scroll back up, you could add all of these to Report Builder, and you could go on with building a report on 3 or 4 AISI. Next, we're going to head over to Physical Properties. As you see, physical properties are set up in the same way. We have both synthetic view and details view. So let's say we just want to see property values at over 300. We could just quickly add that in, unclick the room temperature value, and see we have modulus of elasticity at over 300 degrees, Poisson's coefficient, CTE, thermal conductivity, and electrical resistivity. And for example, if you just want to view property values at over 300 for modulus of elasticity, as you see, under property, we have selected modulus of elasticity, and we have 3 conditions at over 300 degrees that have modulus of elasticity. So you could always view the diagram. As you see, we have 2 different data points. We made a graph by interpolating the data, and you could always zoom into it to find specific data points that you like. Now we're going to go under heat treatment. For this specific material, we don't have any heat treatment diagrams. But as you remember, under advanced search, we could actually utilize heat treatment by finding a material that has all the different types of heat treatment, not just heat treatment data from standards. So if we go to advanced search, let's say we want to find a material under SAE that has all the different types of heat treatment data. Select all these different graphs, click on all of selected, and we found 2 different materials under SAE that have those diagrams. All these different diagrams come with a reference at the bottom, and as you see, this material also has descriptions from standards as well. Now let's go back to 304. Next, we have metallography data. To note, metallography and heat treatment data usually don't come from standards, so this is why Total Materia is such a great asset under the data modules. Let's say we want to search for a specific condition, so we don't have to go through all the different diagrams, and we want to add it to Report Builder. We just quickly scroll back up and add the diagram to Report Builder. Of course, we have machinability data as well as chemical composition data coming from different standards. And if you want to quickly see different substance inventory list, you could click on the CAS number here, and it'll automatically take you to the compliance module, and you can see which substance is listed under critical raw materials as well as conflict minerals. Next, we're going to go to stress strain diagrams. We could also search for conditions based off their heat treatment, form, and strain rate. So let's search for a stress strain diagram under billets, add a strain rate of 0.1 to 1. We found 3 different stress strain diagrams. We have different temperatures. Let's say we want to export this data. What do? We could just quickly scroll back up, click on export. Let's say we want to export it to ANSYS. You could also select different properties if you'd like. Select the condition that we were on, and select all the temperature values. And you get a zip file that you could quickly just import to ANSYS. And that's how easy it is. And if you want to access your previously exported file, you just click on Exporter and you could find that file over here. Now let's go back. As mentioned, we have formability data as well as fatigue, fracture mechanics, and creep data. We're just going to go over fatigue data very quickly because we have really good data points for low cycle, so strain life parameters, as well as high cycle fatigue data, stress life parameters. Again, we could do a specific search on our different conditions based on heat treatment, form, specimen, direction, loading conditions, as well as stress ratio. But if we scroll down and we go to the annealed condition, we could find elastic, plastic, and total curves. And if you want to compare the three curves at the same time, you could click on Compare Data on Hover and quickly compare all their data points at the same exact time. You could find your stress strain cyclic curve. This is where you could find a material's ascend curve, as well as fatigue strength at the number of cycles. Under joints, you could find welding, brazing, and adhesion data. So for example, let's say we select this first condition, we just scroll back down. We could find information on the electrode. By clicking on the electrode, you could find its chemical properties, as well as if we go to joints, you could find which materials this electrode could weld. You could find all the joints data down here, and as well as the reference. Next, we're going to go to corrosion. As you noticed, only the top 200 conditions are displayed out of the 10,000. You could go through all these different conditions, but you could actually search for a condition through different mediums. So let's say we want to search for a condition through nitric acid, as well as the concentration. We could also search by different properties available, corrosion types, out of nitric acid, as well as the different diagrams. And voila, we could find an isocorrosion diagram under nitric acid. And we could compare its boiling point curve to corrosion rate. And you could change the data points over here. If you want to do a more in-depth search on corrosion data, I suggest for you to go to the corrosion module. Over on the corrosion module, you can see all the different mediums available, its concentrations, as well as medium temperature. And most importantly, all the properties available we have in the database. These are the most common properties: corrosion types, different test methods, as well as all the different diagrams. Lastly, we could find all our suppliers' data over here. For example, if I want to see where I could purchase this material in the US, also pick the form of the material. So let's say I want sheets, and then I could see which distributors and producers actually sell and produce this material. Now we want to find similar materials to 3 or 4 AISI. Where do we go? To our cross-referencing table. We've separated this table in different categories, such as identical, meaning that these materials are fully identical to 3 or 4 AISI. If you want to quickly compare those materials, you could click on these 2 arrows, and based off of the different subgroups, which you could also switch, you could compare these 2 materials quickly. Under synthetic or details view for both mechanical and physical properties. And if you like to, let's say, add the chemical composition of the comparison between 3 or 4 AISI as well as 3 or 4 SIA, you could click on Add to Report Builder, and you could get on with your material selection. Next, we have official. Official means that these materials are given equivalent based off of SDOs. Composition 100% means that these materials have the same chemical composition, but that's not given as identical or official by SDOs. These materials usually come from producer data sheets, or they're not listed as identical or official equivalents on their standards. Other sources, this tab means that these materials are similar, but they're given by other sources, meaning that they're not similar based off of SDOs, but usually, as I mentioned, producer data sheets or different engineering textbooks. These materials are implicitly related to one another, and that's formed within the Total Materia database. Lastly, SmartCross, a patented algorithm that could search for similar based metallic materials. For example, if you want to search for a material that has similar mechanical properties, you switch this all the way on the right side. If you want to look at a material that has similar chemical composition as well as mechanical properties, you put this toggle in the middle, And you could also select the similarity thresholds. And throughout all of these different tabs, you could also select which country you want to specifically see in case you're looking for a similar material from a different SDO. We also have a tool called the Equivalence Finder, which we'll go over with non-metallic materials because that's best utilized if you can't find anything under the cross-referencing table, and that happens much more often with non-metallic materials. So now I actually want to compare and create a list of equivalent materials to 3 or 4 AISI. I'm going to highlight all these materials, add them to my material list builder, and now I'm actually redirected to Material Console. I found 26 materials in my list builder, the 25 materials I just added in, as well as 3 or 4 AISI, which I previously added in the beginning of this webinar. I'm going to save this list as 3 or 4 equivalents. I could also add these materials to a previously existing list. My material list was successfully saved, and I could always view all my saved lists through here as well as through my console. And now I actually want to compare all these different materials. What do? I quickly highlight them and add them to comparison view. We have 3 different ways to compare materials. Under materials, this similarly looks like to the quick comparing tool where you could quickly compare their chemical compositions as well as mechanical properties and physical properties under both synthetic and details view. And this tool is great if you want to pin up to 4 different materials, look at all the materials in a detailed manner, and if you want to add the pin materials to Report Builder. Next, we have properties. We could either add different materials like this to properties comparison, but if you want to add in all 26 at the same time, I would just suggest to go back, highlight them all again, add them under properties, but the only problem for the properties module is that you could only add up to 20 different materials, but under materials and analytics, you could add up to 100 different materials. So let's say we want to just compare yield strength. And lastly, we have analytics, a great tool to use if you want to compare many different materials and 2 properties at the same time. Let's say we want to compare yield strength, set this to minimum value of at least 400, and a tensile strength at 900. If we click on Show Results, the grayed out materials means that they didn't make the cut, and the criteria to my yield strength as well as my tensile strength value, so those are grayed out, and the blue ones mean that they made the cut. These few materials do not actually have the values that we chose, so that's why they're not included in the diagram. These points are made up by the average of the ranges that we see. So for yield strength for this specific material goes from 190 to 500. That's why the yield strength is set about at 350 megapascals. And if we want to view the ranges in rectangles, you could quickly see your criteria, and all the materials that are colored, as well as in this quadrant, of course, make the cut. And let's say we're looking at this material. This is material we want to choose, and there's such a large range from 228 to, let's say, 1,200 for yield strength. If we want to compare all the different conditions uniquely by this material, click on the material. Now I could compare this material's yield strength values to temperature values and compare different conditions, as well as different temperatures. Similarly to tensile strength at the bottom. So that's a great tool to utilize once you actually decide which material you want to use. Now I want to finish saving and share my report on 3 or 4 AISI. So I quickly go to Report Builder. I built my report. As you see, this was cut off at the bottom. I could just quickly scroll down, add in a page break, and now my report will be nicely done, as well as add in a page break between comparison and have a good looking report. Now I don't have to take screenshots no longer. I could just quickly save my report, add in a description. I could also add in a title to this report by adding plain text over at top of mechanical properties. I could also download this PDF, as well as share with anyone who has a Total Materia account. Now if we go back to my console, I could find all my favorited materials, my bookmarks, saved searches, material lists, as well as saved reports. Now I want to access a previously saved search that I've done through Advanced Search. I was looking for aluminum and copper alloys under the SAE standard, and I wanted my minimum tensile strength to be from 200 megapascals to 400 at a temperature of negative 100 to negative 50 degrees. Since I saved that search, I don't actually have to input it back in to Total Search, and to go to Advanced Search, I could even access it through my homepage. I could click on Save Search and access it over here. I found 33 different materials. If I want to quickly see which materials have stress strain diagrams, I could highlight all these materials, forward it to stress strain, and I have 17 different materials that have stress strain diagrams. You could choose between direct data and non-direct data. Direct data means that this information is coming from the specific material. And if we click on this material with a star, that means that this material does not have direct data, but you could actually find stress strain diagrams of similar materials. And you have your equivalency category over here. Now I actually want to see if these materials are compliant to RoS 2015. I just quickly highlight these materials, add it to my material list builder. I could sort these materials again through alphabetical order, and I could add them to Compliance Assessor. I can choose the country of regulation as well as the specific regulation. Click on Assess, and I'll be able to see which of these materials are compliant to that specific regulation. The middle three materials are, and they're highlighted in green. This means that there's a large unknown amount in the chemical composition, therefore we can't fully say if this material is compliant to that specific regulation. For example, you could only have a 0.01 percentage of lead, and since there's a larger percentage of the unknown, we can't fully say it's compliant, but you could actually see the exemptions for different applications, and maybe you could actually use this material considering the different exemption. If the material was not compliant, you would see a red status symbol over here. And if the material contained chromium, you would see that the material is compliant, but it's just warning that it contains chromium, meaning that hexavalent chromium could appear under different applications. And of course, you could always pin these different materials and add them to Report Builder. Now we're going to go over a non-metallic item. We're going to clear our search and search for Makrolon 1095. I could also input the producer name here to find all the different materials under that producer name, and I could select which polymer I'd like. We have our polymer set up under thermoplast, thermosets, as well as thermoplastic elastomers and thermoset elastomers. I found my material. And the way non-metallic materials are set up is similar to metallic materials. You could also favorite the material, add it to Report Builder, add it to Material List Builder, export that data, and bookmark the page. You could find all its producer information, as well as the material group, its family, and we could see that this material is a polycarbonate, as well as an indicative price, and you could also see if there's a filler. As you can see, mechanical and physical properties are essentially set up in the same way, both under synthetic view and details view. But under physical properties, since there's a lot of different physical properties for non-metallic items, we actually have them in different tabs. Under general, we have properties like density and water absorption. Similarly, you could utilize the condition selector and look up all the properties at once, and also the different states and forms of the material. We have thermal properties, flammability ratings, electrical properties, as well as rheological properties. And under rheological, if we click on all the conditions, we could actually see that there's different multi-point data, like shear rate strength versus shear rate, like shear strength versus shear rate diagrams. Of course, we don't have heat treatment data, machinability and metallography data for non-metallic items, but we do have manufacturing processes. This material could be manufactured through drying or injection molding. We also have stress strain diagrams for plastics. We have different joints data. We have enviro data. Under corrosion for non-metallic items, you could see if this material is chemically resistant to specific mediums. And lastly, we have compliance data for non-metallic items. Over here, you could see which regulations this material is compliant to. Under ROS, you could also view the exemptions and substances, inventory lists, hazards, transport. As well, you can see if this material contains a conflict mineral. Now, if we want to find a similar material to Makrolon 1095, I could click on the cross-referencing table. We have 21 different plastics that are similar to Makrolon 1095. But if I go under implicit and click on this comparison, there's not much information for this material that I selected. We only have impact strength for mechanical properties. So that's where you could actually utilize Equivalence Finder. Under Equivalence Finder, you could search for materials that have similar property values to Makrolon 1095. So let's say we're looking for a material that has similar properties to Makrolon 1095, such as tensile strain, yield strength, maybe CLTE. We have different search sensitivities. High means plus minus 1%, medium plus minus 10%, and low plus minus 15%. If you think you might forget what these search sensitivities mean, you could just scroll back up and click on the question marks bar to see all the different data and the defining parameters. Now we cross-referenced through the database and found 368 materials that have similar tensile strain, yield strength, as well as CLTE values to Makrolon 1095. Let's say we only wanted to find polycarbonates. We just scroll back up, click on chemical composition, and now we're going to just search for polycarbonates. Out of those 368, we found 279 different materials. And let's say we want to change our search sensitivity, and we found 10 different materials that have very similar property values to Makrolon 1095. We can see that the yield strength is identical. The tensile strain is ranged, but if we click under Details View, you can see the different tensile strains, 4.6 and 6. And that's how you could utilize Equivalence Finder to find materials with similar property values. Now, if we scroll back up, something that we didn't go over is material description. Under material description, you could always find more data on the materials, such as different applications, processing methods, as well as different comments, maybe on the fillers, as well as the appearance. So let's say we want to find different materials that could also be injected molded. Go to Advanced Search, and under Full Text Search, add Injection Molding, click on Exact Phrase, and now it's going to cross-reference the whole database, all the different descriptions on polymers, and see which polymers actually are able to utilize this process. And we found over 2,000 different materials. Let's say we want to find recyclable polymers that are also able to be injected molded. We could add in recycle to our search and see if any of these materials have recyclable components. And voila, we have 326 different materials in the database that have recyclable components, as well as can go through the injection molding process. And there you have it. That's a quick description of all the different data modules and functionalities that Total Materia has.